Hi guys, and welcome in the next video. So today I wanted to talk about a little bit of a broad topic, and we're not going to focus just on FANUC, KUKA or ABB, but I wanted to talk generally about something that you will see in basically all of the robots. And that topic is robot collision zones. So I hope you're going to enjoy it, and like always, let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, so what is a collision zone? So you will use them when you have more than a one robot in a cell. So when you have two robots in a cell, you might need a collision zone. So basically the collision zones are created in order for two robots not to meet each other or not to crash into each other. Are they always necessary? No, but depending on how many robots you will work with, most likely one day you're going to come across collision zones and the issues that comes with it. So just like I said very simply, we will use the collision zones to tell the other robot not to enter some area of work because the other robot is performing work there right now. So if we have robot 2 and robot 1, if robot 2 is right now in that zone, he'll tell to robot 1, hey, don't go inside because like I'm working there, please wait for me to finish. Then he'll go out, robot 2 will go in, robot 1 will go in, do his stuff, and the same. Once he will be able to go in, he'll say, now it's my turn to go in, do my work. After he's done, he'll go out and the station is, or the process is going to be completed. Probably you're going to ask, okay, we can use other things for it, like handshakes, we can use different programs, and we can let the PLC control the zones. Yes, you can. However, the general rule that I try to follow, and I will encourage you to follow, is whenever there is a possibility of two robots meeting in one place, you should use a collision zone there. If we're talking about different programs that PLC will not send at the same time, then yes, you can forget about the collision zones. Let's say that robot is running PNS1, then the other robot can run only PNS1 or nothing else. So you need to worry only about the same programs. The question will be to you, what type of programs you're running, how does your robots operate, and can the PLC send only one type of a program to all of the robots, or it can send any program to any robot. Then you need to determine whether or not you need a collision zone. Following to that topic, you'll say, okay, we have also handshakes. Yes, you do have a handshakes, but again, the same rule. If something will go wrong on the PLC side and it will let the robot in for any reason, then what's going to happen? The other robot will come in. So you should use the collision zone anyway. You can say it's double safety. Yeah, I think it's better to have double safety than one chance of crashing the robot. So it's always, like we say, better to be safe than sorry. So that's pretty much it about the collision zones. I'm going to show you on an example that I prepared for you, how they work, how to set them up, and what will happen if there was no collision zone, and you're going to find out how they work. So let's get to the exercises. Alright guys, welcome to the exercises. So I prepare a training cell for you. So basically what's happening here is we're taking an raw block, we're putting it into a CNC machine. The CNC machine changes it to our tool here, and that tool is being picked and being placed in one of those three shelves, and then the other robot picks it from the shelf, cleans it in here, and then it's putting the tool back to the station in here. So then the operator can collect the tools after the cycle finishes. So I hope you already see where we can come with an issue actually where we need a collision zone, and that is the exchanging here. Because what can happen is both robots can come in there at the same time, and that's going to cause a collision. So we don't want that. So I'm going to show you a few examples. First, I'm going to run the cell so you'll see how the process look like. I'm going to show you what's going to happen if we don't have a collision zone. And in the end, I'm going to show you what will happen if we do have a collision zone. So let's get started. Okay, let me start the cell. Let's start the robots and you'll see how everything plays. So as you can see, that robot is going to pick the block from here. It's going to place it onto the CNC machine. Then the CNC machine will do all of the process in order to receive a ready piece. And then once the CNC is finished, the robot is going to pick it up and place it in any of the 3 shelves. So the CNC is working right now. We're waiting for the part to finish. Okay, the part is finished. We're going to pick it. And the other robot basically is waiting for the first robot to place the piece in here. And there is a part presence sensor over there. As soon the second robot will see the part presence sensor, it will start executing the motion. So as you can see, we're putting it, and immediately the second robot starts its motion. And that seems to be quite fine and works okay, because the timing seems to be okay. That robot gets out before this one is finished, and everything seems to be fine, yes? Okay, so I'm going to simulate a fault on the other robot. So at the moment of the picking the first part, the robot is going to fail right after the pick. So it's going to come to the pick position. It's going to lift the part. And the moment he will lift the part, it's going to basically fail. So it's going to stop for any reason. Let's say he didn't grab the part properly, and that's it's causing us an issue. So let's see the robot behavior when that happens. As you can see, the first robot started picking the next piece already, and it's going to place it into the CNC machine. And the first robot and the second robot we have here, it's almost done with the process, with the cleaning process. And he's going to take the piece, put it back to the station. And let's see what's going to happen right after it. Okay, so as you can see, we have 2 pieces ready. The first robot already finished placing the piece. It's going to pick the piece that's free. In our case, that's going to be number 1, but he did fault. So he lifted the piece, he did lift the piece up in the floor, so the part presence sensor is no longer being made. Let me show that on the robot itself. So as you can see, the first part present is not on, the second one is on because we have the piece in here, and the third part presence is also off because we have no piece. So that robot, what he's going to do, he's going to check what's free, and the first one is going to be free, and 2 robots are going to collide. See? This is what happens when we do not have a collision zone active. So now let me take that fault away, and I'm going to enable the collision zone on the other robot. So this time when we're going to pick from here, we're going to also fail, but we're going to have the collision zone on that will prevent this robot from picking. So let me show you how this actually looks on the robot side. So on the robot side, we have a signal in here that's called clear of zone 1. So the moment that this robot is trying to place, he's turning off that clear of zone 1. So basically he's saying to the other robot, hey, do not go in there anymore because I'm there. The moment he finishes, he's going to turn that signal off, saying, hey, I'm clear of the zone, you can go ahead and pick from any of those 3 places. If you ask me if we can create 3 different zones, 1 for each pick, yes we can, but for that example I just created 1, so you can see the process. So as you can see, the second robot is still working on the cleaning, but it's almost done. It has only 1 more pass left. And this robot is going to pick the piece from the CNC. It's going to wait for a free spot where he can drop it. And right now we have collision zones enabled on both robots. So basically what's going to happen is we're going to wait for this one to basically finish the process and pick the next piece. And again, this time he's going to pick it, but with the error and with the collision zones enabled. So let's see how that goes. So as you can see, we already placed the piece. He's going to pick the part. He's going to fail, and please take a look at the teach pendant at the program, what's going to happen. As you can see at the beginning of the program, I'm waiting for entering the collision zone, but the robot cannot enter the collision zone because the second robot took that collision zone. So when you take a look at the input, number 25, that's coming from this robot to that robot, you can see it's off. Off meaning that collision zone is not clear to enter. The moment that the robot will clear that collision, we will continue with our program pointer to the next line to here, and we're going to take our collision off. Now, this is just a RoboGuide example, guys. So please keep in mind when you set up the collision zones, you usually need two signals, not only one. One is to request to enter the collision zone, and the second one is the actual clear of collision zone. I'm not going to go in details in that video about it, but we will cover that in the future. So let's continue. I'm going to clear the fault on that robot. So he will continue, and the moment he gets back home, take a look at the signal cleared, and that guy goes in. As we go in, we turn off our clear of zone. And that's pretty much it about the collisions. If you have any questions, feel free to leave them down in the comments. Don't forget to subscribe and hit that like button. Thank you, guys. All right. Thank you so much for watching the video. Please don't forget to subscribe, give it a like, leave your comments down below. See you in the next video. Bye bye.